better. Okay. So it's inevitable that working with optics will eventually lead you to some nasty type errors. We've had this happen a few times, but it hasn't been terribly hard to figure out, but I guess it's not easy. There's a lot of wonderful functionality hidden behind lens combinators to great power. With great power comes great complexity, and sometimes the abstractions leak a bit. It's impossible to avoid these errors altogether. Most important thing is to not get discouraged when facing complex error messages. The secret is to read the message, break it down into pieces, and use some heuristics to help understand the problem and practice, obviously. I don't exactly know when we'll be using a lot of lenses in our code, but anyway, it is what it is. Like, I don't know how much practice that we'll have actually optics. We'll have to see when we come to the next project. I mean, I guess we could make it a focus of the next project to use a lot of lenses, but I don't know that that's a good idea either. We'll have to see. Okay. Spend some time trying to solve it before asking for help. It'll improve your error reading skills. Yeah. Be friends with your compiler. We agree with that. Oh, this is cool. Okay. We've already learned a little bit about Van Laarhoven optics. How Van Laarhoven? I'm sure I'm pronouncing this wrong. Are represented as part of a custom traversal section. Okay, let's start with a little case study and see where this technique can help us troubleshoot problems. Okay, so the way I set these projects up is I just kind of have like weird named uh, examples just via letters because it would be too complicated to come up with good names for all of these things. Um, oops, that's not the right operator. None of these will be in scope, so we need to import control lens, and we get an error. Yeah. Could not deduce. Yeah, it's a little bit different, but we're using a particular version of GHC, so it's no big deal. Arising from use of folded. Okay, so yeah, because we're using a fold here, we can't actually set anything. I'm pretty sure that this just needs to be traversed and then it compiles. Yeah. So a fold doesn't actually allow you to use the set, but we'll see. So I'm guessing that this is what we're going to talk about, contravariant. Something went wrong. The important part of the error message is right at the top. Could not deduce contravariant identity. The first step is to separate the relevant data type from the constraints. In this case, we have contravariant and the data type identity. We know that we have a mismatch because identity doesn't implement contravariant. We can look in the optics ingredients table to see that we expect to see identity when running modifiers like set or over. So it makes sense we'd see it running into, so this is multiplied over, which modifies the value via multiplication. That means our problem lies with the contravariant constraint. We have two optics it could be coming from, either folded or first. I don't know what people call this in English, probably just first. You can look up contravariant in the table to learn that it's typically required by folds, and folded is a fold. Variant in the table and learned it. Okay. That discovery means that we'll need to change folded to something without out. Could not deduce. Oh, I see. Okay. So folded is actually a stronger guarantee. You can look up contravariant in the table to learn that it's oh, I already read that. Looking through the table, we see that traversals don't have a contravariant constraint. They have applicative instead, and identity implements applicative. If we stop folded for traverse, it should work out better. Okay, so I was correct in what I should do, but not why I should do it. Okay, so let's look at this. So this has a traversable constraint, but if we do folded, whoops. So this requires I don't see where it requires. Sometimes it can be, I don't know. It's really hard to figure out this contravariant, like why it's that way. But anyway, I'm pretty sure that this process isn't always so straightforward, but it's often a good approach to take. Um, to at least understand which constraints are at play in your expression. The more you practice, the more you'll start to remember which optics, constraints, and the whole thing will become easier. Great. So I think that Chris just released like a cheat sheet or something to optics. I wonder if that table is just on there. Right. So I think we're gonna have a war with errors. That's gonna be fun. To help you build error solving skills, we'll practice them in a safe environment. Welcome to the type area arena, where you and your wits will face off against the most devious of Lency type errors armed with nothing but GHCI and its sometimes arcane error messages. I'll present you a puzzle in the form of an expression. Da, 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 da. Okay. Here we go. First foe. Um, so we'll do this in HLF, I guess. Okay, so this one is a lot simpler. This is just an import control lens deal. Um, yeah, I don't think that this one's particularly hard. We don't have the operator view. Okay, Tuplican. It's a weird name. Equals. I can write equals, I swear. This is just backwards. The problem is I'm not reading the error messages. I just kind of know. So, but like if we just look at the error, um, we need to we need a getting. We need a lens. We don't have a lens. This is just like data. So, we need a lens. Okay. I think that one's kind of easy. Oh, I see. Like these are kind of like. So I guess this is supposed to be like um, duplicant. And I'm not sure what this one's supposed to be. I also have no idea if my chat is working. Is anyone there? Just to make sure that my chat is working. You don't have to speak anymore. Okay, great. Thank you. I haven't seen anything, so I'm just checking. All right, so let's get this one in here. Call this D. Um, hey Joel, how's it going? And Commander, I don't think I know your first name. Maybe I do, but it's always hard because names are hard. All right, so what do we got going here? I mean, okay, yeah, like this is just because we're using the wrong operator here. That's supposed to be an ampersand. Um, I feel like I'm not really reading the errors as much as just like knowing Haskell, if that makes sense. Like we've almost never used a dollar sign in lenses, so it's kind of obvious. But anyway, it does say first argument of dollar takes an argument, and it's given this whole thing. Um, so it's unhappy, I guess. Okay. Um, I guess this is supposed to be a manticore. Okay. So these are composed in the wrong order. Um, this is like we're reading this three after one, but lenses compose backwards in like kind of a weird way. It's like dot becomes then, so it's like one then three instead of three after one. It's kind of weird. You have to get used to that. I don't know how else to explain it. dinosaur. Well, I guess this is maybe Tyrannosaurus. I don't know what saurus he's looking for. I suppose it's a villain of some kind. I wish it was Foldaraptor. Something like that. Okay, so let's see here. To then just no instance for monoid int arising from the use just. Right. We need to be able to mempty. So what's the we need a dollar sign or a question mark. Sorry, it's this one, this one. Yeah. So if we use view, the monoid is required because we have to be able to do something for nothing, and in this case, we can just ignore the nothing completely. Okay. Tiger or beast. Don't really know what that one's supposed to be. Okay, so we're on G. Go. Okay, so to list of these look backwards. If I had to guess. Okay, so this one's tricky. Yeah, I think it's like just um traversed. What is it? Traverse of? Is that a thing? But then we don't. I don't think we really need this. I don't remember how to use taking. Okay, let's read the error. Let's be smarter about what we're doing here. So we expected heading. Idea what R is. It's tricky. Take made here is more substantial than in other problems. So let's look up taking. It takes an integer. Is this another traversed or something? It's the same thing. I don't remember how this works. But then why do we need this? Like, isn't it just this? Should be good. Gee. I mean, that looks right. Can we just do folded here? I can't remember. Probably. I think we can use folded or traversed here. And I guess folded is a stricter requirement from the previous one. So this should behave exactly the same. Okay, cool. So remove the dot. It's because we're missing a traversal. Cool. Ooh, this one's funny. It's like Dracula. So we have H. I think this. What? This one just doesn't complain? Oh, here we go. Okay. It only complains when you run it. Yeah, so I think that to do this, we need traverse of this one because yeah. So this is just, I just remember that this exists. I don't think that maybe there's a more simpler version of this. No, there isn't. It's just that. Reverse. Wait, that's it? Okay. I guess we're done. Um, with chapter 12. I didn't realize that this was going to be this short. So let's go up a directory, format the code. Is that a snail with a Christmas hat on? Sick. Very cool. Uh, I guess I wasted a lot of time making this into a stack project, but that's okay. So we'll merge that here in a second. Actually, let's just do it now. I don't really wanna wait here. Um, that is pretty sick. Optics. Okay, so for anybody who isn't familiar, there is the book we're working on, and we just finished chapter 12. Just quickly merge this so that I don't have to do it later. Now. Okay. No. Back here. Okay. Let's check how long this chapter is. Only I kind of like having. I'm not going to make a different branch because we're probably going to finish this today. I think what I'll do is just work in master from here. We already pulled, so that's not going to work. Okay, so okay, make a new project. This can go away. Do 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 do. Okay, we'll get our sort of everyday stuff out of the way. Oops. Source this, app this, delete this. I should really just make a template, but it's like, I don't know. Is it really worth making a template? I don't think so. Ticks and monads. Yeah. There's another book. I really should get back and finish that book. And also, I kind of would like to work on a project that requires me to use the technique in that book. But I feel like you need to do something intrinsically mathematical. And I just don't have any problems like that right now. Okay, so uh, let's get control lens, and then we will do this. So because I'm a monster, um, I yeah, I don't think that there's a discount on that one right now. I'm gonna check. Oh wait, I don't think Sandy posts on Twitter anymore. Um, but he does have a website. Maybe he has a deal right now that I don't know of. So because I don't know, I want to do it this way. I'll just use new types for everything. And we'll just like update the code where it needs to be updated. Sure, we can use current user. I don't really care. Users, map, username, password. Sure. Interesting. We need what? Oh. Haha. I'm being a goofball. Okay, that one, that should be good. And make lenses, and then language, template has, oops. So for reference, anybody new here, the goal is to finish this book by the end of the year. And then next year, we're going to start working on a website. So yeah, if you're curious about what's going to go on in the next few weeks, that's what's going on. Okay. We also still have another book to finish, which I do want to finish next year, at least one book next year, but we'll see how it goes with the website and stuff. I might get engrossed with that and just keep working on it. But it's always Haskell around here if you're unfamiliar with the channel. Okay, so we have our env lenses, so we should now have a username, password, current user, and user's lens, I believe. I don't think that I need to like tell it to generate lenses for these, but maybe I should. I actually don't remember how that works. So let's just get lenses for everything so that we just have them. So we're gonna make lenses for password, and we'll just make them all here. Good enough. Okay, so now we're gonna have this function called print user. We need to get reader. Really? It doesn't want to figure this out. Okay, so package, we need transformers. We need to restart our COC. Yep. And then we can go back to lib, depending on how you pronounce it. And then we should have this. So we can just import that. This, oops. This should come from, oh, I pressed the wrong button because I'm a goofball. This should come from 3. And what's this complaining about? Yeah, so asks okay, so again, one issue here is that we need to reach into users because users is this. Oh, sorry, we have a username which is embedded into a username, so we need to pull that out, which is this. So we could have also just done this is perfectly reasonable as well. You can just write this, it's exactly the same. So just keep that in mind if you're new to Lens. I don't know who is new to Lens here, so let's just not have a main function outside of this, and we'll just say I don't know, we'll just call this A because that's again kind of how we do things. Run reader T, print user, and then we have to give it an initial environment, Jenkins, singleton, Where does Hunter 2 come from, by the way? Hi, Joel. New to Lens. Thank you for stopping by. Lens is sweet. I think that you would like. Well, I don't know if you would like it necessarily. It can be pretty tricky at times, but you can do some wild and wacky stuff with Lens. I was waving at you for being new to Lens, by the way, not because I didn't see you before, for reference. Um, but yeah, I think Lens is super sweet. I'm having a lot of fun with it. But again, I'm not exactly sure when I'm going to use it in real life yet. So we'll see how that goes. Yeah, it is some password meme. I know that, but I don't know where it. I'd like to know where it's from. And hey, Prutz, how's it going? I feel like no, I saw you pretty recently. It hasn't been that long. Okay, so what we need to do is just embed these things. Now we could do some. Let's do some fun lens stuff here. Ooh, okay, you found it. Okay, hopefully this is fine to show. Hey, okay, nice. That's funny. Okay, so now we're gonna do some lens shenanigans because it's fun. So we should have. So this is gonna be a username. So what we can do is use the lens. Um, what is this called? This is called a prism. I'm pretty sure. Um, and you can use a prism to construct a username. So basically, this is going to be given a string, it will construct you a username. You don't need to do this, obviously. It can just be username in front of this, but I'm just doing it for the fun. So the same thing is true here. So we can write username. Oh, actually, what we should do, because we're not monsters, is say let username Jenkins spell, and then plop that in there. Like so. Oh, do. Okay. And then this one, the password is also something similar. We can write password hunter 2. Okay, so can you do username asks username current user here? Let's see. Yes, I think so. I don't see why not. It would just change the way we initialize reader T, right? I think. Yeah, it would just. Oh, I see what you're saying. Yes, I think. Yeah, we could absolutely. So, I see what you're saying. User name like this, and then we can remove that. I think we should compile. We need to add that parenthesis, and then maybe we'll get a compilation. Yeah. So like this is should be exactly the same because asks will just do this thing, and then we can just pull this out. Now I'm guessing that we can also change these to the lenses, but they would have to be flipped, would be my guess. So I imagine we can do current user and user name. There's probably like a lensy ask that we need to figure out, but I'm guessing we can do that as well. Okay. Yeah, there it is. The equivalent lensy version. Oh, okay. So view is just that. That's pretty wild. And then we just change this to current user.username, and then I guess it works exactly the same. That's crazy. That's really cool. So why does this work? Because reader T, a reader T defines some kind of lens, I guess. Okay. This is actually the exact same view function we're used to using with lenses. Here's the real type of view. Monad reader SM getting ASAM. View takes an optic and returns an action in some monad reader, which returns the focus. This works in standard non-monadic case because functions have a monad reader. That is, the function SA is a valid monad reader. If you haven't seen this before, it can be a bit surprising. Have we seen this before? I don't remember if we've seen this before. Preview works the same way. This means we can run folds over the environment and get back a result wrapped in maybe. Kind of interesting. So we're going to write another function, get user password. ASA. I guess it's, yeah, where's the structure? But you have the structure embedded in the reader. So I guess you don't need S2A at the end. You can just have MA. That's kind of what's replacing, right? Yeah, I think so. I think I understand what you're saying here. Raiders. Hey, Raiders. How's the rest of your stream? I was sort of distracted while I was watching, making sure I got your stuff set up. So, raid. So many A's. Okay, so we're learning about optics, specifically learning about how to use optics with like reader T, for example. Got some failing tests to fix for next time. Nice, perfect, very good. Oh right, yeah, you're building that that structure I didn't understand, and I'm blanking on what it was called, chronofolds or something, some kind of data structure. Env unit get user password, and then this will be a do. Yeah, CRDT. CRDT. That was actually something I meant to look up after your stream last time because I don't remember what that stands for. Something data type, obviously. Recursive data type. C. What would the C be? I don't know. Conflict. I was kind of close, I guess. Conflict-free replicated data type. Something I should look into for sure. Need to write that down somewhere. All right, so user is going to be view current user, and then m password is preview. Okay. Lift.io print m password. Okay. So we need some deriving shows. I will read the rest of your statement here in one moment, but I need some show instances. Okay, so right. So users here is that, and then wait, isn't this right? So uh, yes, function is also a monad reader S. Yep. Stuff that powers Google Docs, for instance, for collaborative editing. Oh, okay. That's cool. I didn't. All right, so what's the error here? So, oh, just no instance of ord. Um, we can just derive. Actually, what we should do is do. How do we do new type deriving again? New type deriving Haskell. That's what we should do. Isn't there like a deriving something? Or it's like deriving via or something. Yeah, okay, it's just deriving. So yeah, I think that these are just saying like instead of instead of trying to derive anything for username, just derive these or just use these instances for string or from string. I think that's what that means. Obviously, we can't do that for the other cases, but I think this just works here. Okay, so operational transformations is one of CDT. Ay, ay, ay. These are hard. Okay. Anyway, we have now this, and we want to just change print user to actually let's just leave this here, and then we'll do a B get user password, and then we'll run both of these. Stack REPL code. Okay, so A is printing the user, so I guess we're just gonna get Jenkins or something. Yeah, with current user in front of it, sure. And then this for this one, we're going to get a password for the current user, I guess. So it should just do, yeah. And then if we change this to like derp, we should get B is, wait, what? Think what? Oh, right. The users match. I'm being stupid. Sorry. Uh we would need to put username Jenkins in here for this to fail. Sorry, I'm being silly. Um they were the same, they matched in both places, so nothing has changed. That's not what I wanted to do. Um so now we get nothing. Okay, cool. So we'll just leave that there. Here. Nice. Using view is the idiomatic way of accessing your environment if you've got lenses defined in your environment. Great. State monad combinators. State is another common Haskell monad. Yep. The lenses library provides combinators for both accessing and mutating state within the state monad. So obviously this is going to be view and this is going to be over or something. Um, let's explore this with a small example. Write a state monad action, which runs till calculator for recording the sale of a couple beers. Here's so yeah, this, because I don't really care what it is there, and then we need to do that. This here, move that over, show. Okay. Okay, so there's that, and then we don't need these parentheses. Make lenses till. Our simple till can hold a running total number of drinks in an order. It also keeps a list of all sales. Holds the current tax rate. Write up an action which represents the sale of a few beers. Okay. Sale calculation. State T till IO unit. We need this. Sorry, wrong button. That one. Sure. Okay, so, well, different names. They will have dot equals, plus equals, and star equals and stuff like that. Yeah, that makes sense. I guess it doesn't make sense because I've not seen those equals before. So it's a little bit different. Fine. So sale calculation. Total dot equals 0. Okay, so this is a setter for state, which is cool. And I guess that if you have a numeric type, you can use this plus equals and times equals. And this should be a, oh, right. This is actually, this is being, does this bother anyone? Well, it's a num, it has a num instance, so it's totally fine. Are we intimidating people? I don't think we're trying to intimidate people. But, well, maybe we are. So this is like basically initializing the state of our till with a total. What's weird is that we don't have to do anything with sales or tax rate. So I'm genuinely curious what sale calculation. Okay, so we could, this isn't initializing state T. We're going to initialize state T later when we have like a run thing. This is saying like we're just going to set everything, set the total to 0 for a when we run this sale calculation things. Anyway, yeah, exactly. So we'll initialize later. Yep. Thank you for reminding me though. Hey, Count Oren, how's it going? How are you? Super swell. Learning about optics. So always good. Okay, so anyway, I think that this is pretty clear what this is doing. This is just a set operation. Um, just like, yep, just like this. Okay, so almost all setter combinators have state equivalents which simply replace the tilde with a equal. And equal, I suppose. Here's a type in case you're wondering. Lens, sure, this all makes sense. Okay, so okay. I sort of wasn't expecting it this way, but whatever. 855. I don't know what that was. Or an owl or anything, so hopefully it's okay. Creating CLI tools with Nix to our developers. Fighting with Json, creating CLI tools with Nix for our developers. Okay, that's cool. Um, cool. I don't know what to say to that yet. I need to know what you're doing more, I suppose. Sounds cool. Sounds like something that should be done. Right. So we've added 2 beers to our total, I guess. Um, Now we're using plus equals. Yeah, this obviously like add over, adds a provided number, mutating the state. Great. Um, use, use, use is kind of weird. Printf. Ugh. I mean, I guess I understand why they're doing this, but seriously, printf is the. Yeah, yeah. I thought it was gonna be like I thought it was this was just gonna be like view, and that would be the same, but it's not. I'm not seen use before. I think I've seen. Okay, so use is like view, but for monad state rather than monad reader. Cool. Um, Thinking about, is there any other way to use like, well, the result of our calculation is unit, obviously, but there's probably also something for looking at the final result or something. Okay, so anyway, what number are we on? C, I guess. So state t till io unit. Uh, uh. Oh, we're okay. Um, Exec state t sale calculation till 0. Oh, this isn't state t. This is just io unit. And then we also need a print. Uh, what? T. Let's compile. It does. Okay. Um, don't get the result until right. Yeah, that makes sense. I think. Um, isn't there a way to do this? I guess you could fmap print, but then you need to line it anyway. So you could use what, like traverse underscore or something? Is that right? No, I don't remember how to do this. Oh yeah, yeah. Thank you. I'm being silly. No, you're 100% right. Um, I'm being very silly. Okay, and also means we don't need this do here. And then C should give us basically the total of these things, and also as a side effect, print this. Cool. Neat. Yes. Yeah, but this is like less typing because I can just use print as um a, a function that takes another thing. Okay. Sorry. I can do this, I swear. I don't know why I'm so tired already. I really need to take a nap. Okay, let's see here. So what's sales here? Oh, we're keeping track of all the sales. Okay. So this uses the stateful version of mapend over. I guess I should just say append over or something. You don't really need to say mapend. That's sort of like a side effect, not a side effect, a historical artifact because of the way this was set up, which uses a monoid to append the sale to the focus of our sales lens. So we'll actually just leave this here because this is totally fine. And then we'll say, yeah, no worries. Take it easy. We're always learning. Everyone's learning. I did this backwards though. Oh no, I didn't. Okay, so now we can keep track of our sales, which is nice. Although that's a little awkward, isn't it? What is this supposed to be? I don't know what it's supposed to be, but I have a feeling like this is awkward if we're talking about like I don't know. Let's call this what's today? Tuesday? Today actually Tuesday? Yeah. Sorry, I'm off this week, so days are hard. Um anyway, I feel like this should be like um no, this is awkward. Right? Like isn't this really what we want? Our individual sales and then our total? I'm not really sure what we want. I know that this is just an example, but I'm feeling awkward about it. Um, like there's definitely a better way to do this. I feel like. Yeah, I agree. Uh, but I don't know what like this interface feels awkward, and that's fine. Like it's a contrived example. So anyway, okay, yeah. So I think what's gonna happen here is we're actually gonna get rid of these. Then our sales will just be like I don't know, something like every individual thing. And then this is also awkward though. I everything's awkward about this as far as I'm concerned. So what we need is a total. I what is this tilde thing mean? Yeah, this is just giving me a list. So it's just embedding 855 into a list. That's all it's doing. So that I can append our sales. So here's my idea. I want to change this to make it a little what I would say is less awkward. So the reason I'm saying that is I think that our sales will keep track of our individual sales during the day or something, and then at the end of the day, or sort of like this is going to represent the entire day of Tuesday. At the end of the day, we'll just take the tax rate and multiply it by all the sales or something, and stick that in total. I don't know. I'm trying. I don't understand what this. Oh, here it is. So it's just MBMU. If you look closely, you'll see we don't actually bind the result. We use the, I don't know what this is called. This combinator is a shorthand for running some monadic action and getting its result into some portion of your state. In this case, we run a monadic action to calculate the tax rate, then store it into our total using the total len. When we bind tax included on the next line, we see that it has the tax included. I don't think it's state T that's awkward. It's just like the model that's awkward, I think. So uses tax rate is like an MB, right? Yeah. Okay. Um, and then we need a continuation. Oh, that one went over my head, Joel. I don't know what I want to do here, but it's not this. Oh my goodness. Oh, I don't even see that in my chat. Nah, that's okay. Jump jokes are fine. I don't see his missing message. Maybe it's just automatically removed or something. I don't know. Um, I don't understand what the goal is. I see stars there. Oh, so on my screen that just says it's ACCUMT, ACCUMT. It's kind of funny that it's getting blurred out. Silly twitch. Okay, I don't understand what I'm trying to do here. Yeah, but it doesn't even show up on mine that that's the problem. So I don't know. Okay, let's look at this because maybe this is what I want. Um, yeah, but I mean, I'm trying to do this with state is kind of the point. Um, so we have the sales, and what we really want to do is combine them. So my guess is we can probably do something like we don't want two list of, we want to fold. Why do I not remember how to do this? So we're on page state monad comp. So You want something like sum of, I suppose. We just do. Oh, right. But we need the till, which is. How do we get the till? Use. This isn't. Do this. Did I delete stuff? I don't remember. Okay. Uh, okay. So use use sales sum of. How would we. Okay, so this is like. That's just a list of double embedded in a state T action. And then what I really want to do is like just fold over them, but I don't know how because this isn't gonna work. Uh, something like that's not gonna work. I don't really understand. I'm not sure. Whatever. Then we can just do. I'm just gonna do this the sort of dumb way. To dot equals, I think. Uh, well, that's not gonna work. Um, time x rate sales. And then this feels awkward. This feels awkward as well in a different way. Um, doesn't feel very lensy. Ooh, maybe. Uh, so what is this gonna be? I don't know. Let's just do this. Ooh. Okay, but first we need to multiply all of them by the tax rate. So how would we do that? The type here. This is an S2A. Starts to get really ugly. Is there not a way to do that in between? Because I think you're just using the don't really hope that there's a better lens here, but maybe there isn't. Would like to put something here. Is it just oh, I probably don't. Oh yeah, I will. Infinite match type. Two is doing yeah, yeah. I guess you can embed the sum, but is that necessary? I think that's what you have here. Oh, is it? I think this is actually backwards. Oh, could it match double? Oh, I'm being silly as well because this can just be multiplied. We don't need to fmap. I'm being absolutely moronic at the moment. This can just be tax rate. What we would really like to use right? That's really what we want. Because yeah, yeah, yeah. And then we can just say uh we're being we're being silly. We know the law that uh we should be able to multiply after. Is that right? I don't think that's right. Is it right? This distributive? Am I losing my mind? I feel like I am. I don't care. I'm done with this. I don't love this. There has to be a way to embed this. Yeah, that would work. Yes, I think. But is that actually right? We'll just check because my brain is like completely broken right now. Well, surely I picked the wrong number. Okay, we're good. Okay. Um. What? All right, everyone's gonna have to say hi to the cat because the cat is being very needy. Cat, right, everybody, say hi to the cat. We'll stand up as well. So, okay. This is Layla. Say hi to Layla. She's needy right now. Say hi. Look at everybody. Look at them. Look at them. Look up there. See? Up there. Look up here. Yeah, I know. What are you doing back? Oh, that's not. Oh, the other cat's needy too. You're gonna get to meet both my cats. This is Andre. Here, go sniff the microphone. It's very funny when you do that to me. Go on, sniff it. Where are you going? All right, so you should share that link with me. Probably via Twitter would be best. I am into comfy blankets for cats. Okay, I think I'm just gonna leave this alone because I think that this is probably more readable than embedding those things. Oh, how do we get that? Um, yeah, okay, so oh right, I have to generate this stupid link every time. So Joel, if you email or Twitter me or something the book that you want, I can generate one of these links like this. It's really obnoxious the way I have to do this. Um, I wish they had something more like a creator code like they do in video games. It would be a lot easier. So you could just like um you could just put, I don't know, chiroptical in the name and then it would just work. I don't know. That's a good question, Pretz. They're a little intense actually. I think that this is probably a poor example because there's not a lot of embedding here, right? It's just like we're really not saving that much by doing this at all. Yeah, yeah, that would be awesome. I don't get a ton back from those, but I mean it's better than nothing. And if you're gonna do it anyway. Okay. Um yeah, I did, yeah, anyway. Did we set total? We did. Okay, so I think that this is probably fine. But this is, I don't know. I do not love this at all. It feels real weird. Feels very, very weird to me. I think this is more of like this exists. But I think that it's very weird. Anyway, reader and state monads are wonderful abstractions, but sometimes it's annoying that we need to have the same environment or state throughout the entire computation. Um, the lens library provides combinations which allow us to rescope a reader or state monad to a portion of the type focused by a lens. Weird. We'll start with magnify. Okay, so given a lens and a reader, we can focus. I kind of wish they used. Oh, okay. So we have an A can focus the structure. That's pretty strange. What are you doing? Yeah, I know. You're a cat. Get it. Um. Okay. Anyway, so magnify looks weird. Put this in here. Can you actually hear that come through the microphone? Little cat. Oh. Hey, leave the cables alone. Cables. Okay. Okay, so we got some oops. We got some lenses for weather. Fun. Take this print data thing and check it out. Okay, so we get a float from our environment, and then we just print it with some name in front of it. Okay, yeah, Andre's just making like weird noises. He's being needy as well. I'm gonna have to. Well, how much more do we have in this chapter? Probably not. How long have we been streaming? Only an hour and a half. I don't know. There's not much left here. Maybe I'll stop now. Well, not now, but when I finish this chapter and stream again later for a little longer. I don't know. I don't know what to do. Actually, maybe I'll switch topics. That might be what I want to do because I would like to start getting some stuff set up. I don't know. We'll see. Okay, so print data. This is kind of a weird function because we just like ask the user or we ask the environment for a float, and then given a string, we'll just print the thing. Strange function, I suppose. If we have a weather t, or sorry, a reader t weather IO, we'll need to focus individual stats within the weather so that we can run our print data helper. We can embed print data directly in a reader t weather IO unit because the environment type, or we cannot. Here's how it looks to use magnify. So let's put this here. All right, so inside of a reader t weather IO unit, we can magnify. That's pretty wild. So here is our lens that takes a weather to a float, and our lens that takes a pressure to a float. And then we can print data with, I don't know why temp here, but sure. That's pretty sweet. Kind of weird. This seems useful, right? I don't know. It seems like it would be useful. Okay, where are we at? C. We've only gotten to C. Run reader T. Weather stats. Weather 2. Should be D. Unit. Okay. Neat. I feel like I could see how this would be more useful. You can reuse pieces of smaller functions. Although, like, this is a weird function to begin with. So, I don't know. Sometimes I wish I could see a use case of my own when I'm doing stuff like this. Okay, so you can see that by magnify the reader environment through a lens which focuses on float, run print data against that particular stat. We can do the exact same thing for the state T monad using zoom. So given, yeah, I mean, this is going to look basically exactly the same. Grab this function, which takes, excuse me, a floating point number inside of a state computation, which is arguably a little strange, I suppose, and modifies it. And then we can say weather stats F or something. Sorry, state T weather IO unit zoom temperature convert the freedom temperature. Oh, for sure, 100%, not them. We're actually going to have to build a units library soon, which is going to be fun. For freedom units actually, related to baking and cooking. But we're definitely going to use our own separate types. We'll have to see. I mean, maybe lenses will be useful there, although they aren't going to be that complicated, I suppose. So we'll have to see. I almost wonder if just like pure functions will be easier to deal with. Okay. Zoom and magnify seem kind of cool, actually. Although, again, this is kind of a rough example, only because, like, a little unsafe. X state T, weather stats Fahrenheit, weather 3212. Right, tweak. There we go. We've converted our units of temperature. Okay, so that's chapter 13. We did it. So okay. Do we want to talk about that now? I'm trying to decide. What do people want to do? Do people want me to just continue with lenses or do something different? And by like doing something different means I'm gonna have to set up a bunch of crap, like Nix shells and development environments and projects and stuff like that. So I don't know. I kind of want to just keep trying plugging away at this book until I'm done. There's only a few more chapters, which means we like the goal is to finish this by the end of the week, by the way. So I kind of think that I need to focus and just keep going. Um, so we're going to do that. We're going to keep going. Sorry, I changed my mind. I'm not giving you a choice. No Nix. No Nix for you. You've been bad. We're gonna do Nix soon, I promise. Uh, okay, so let me answer Pretz's question. So the problem with your particular or like what I need to do is for the recipes website, I need to be able to convert units easily and also like obviously parse them and things like that. So my understanding is that the units library has quite a lot of I think that's what it's called. Units. Units Haskell. Right. This is actually the package for making the thing, but this isn't the thing itself. Does that make sense? The actual units package is somewhere else. units defs. Wish there was a link here. That would be really nice. Okay, so units def is the definition of these things. And if you look in here, it just doesn't have all the units that we're going to need. But like there's a lot of units in here, but I don't think all like the ones we need are not in here really. So I think we're gonna use the units library as a mechanism to build our own baking and cooking related units, and then use that and extend that as needed for our project. That's kind of the plan. Okay, we probably don't need this anymore. We'll leave that open just in case, and let's just open up Hoogle, although we haven't really needed Hoogle at the moment. Okay, so we have chapter 14 going. Chapter 14. Nope. 13 package this. Grab all these. Grab all those. Oh, and then yeah, actually we'll have to we'll build the unit conversions between sort of freedom units and non-freedom units. For obviously the trolling internet term. Okay, I don't know why I'm so yawny right now. I apologize for that. It's probably really annoying. Like if I was watching a streamer and they consistently yawned over and over again, that would annoy me. They are colloquially known. I don't know. Well, I mean, I guess that would work. We could use that. Well, I think it'd be funnier if we called them the socialist unit. I'm not going to go down that road. Sorry. I apologize, everyone. Okay, so classy lenses. I think we talked about classy lenses a little bit before. Are these the, I don't remember what exactly these are, but I feel like we did talk about them a tiny bit. Oh, one thing I need to do is stack build, stack test. Yeah, it's like one of these weird, yawning is one of those weird things that is, what's the term? I can't think of the right term. It'll come to me, but addictive is not the term I'm looking for, but yeah, like contagious. Yeah, even if you're not in the same rooms. Okay, so we got control lens, we got everything built, so we should be good. Yes. Just in case you've never heard of classy lenses before, we'll go over roughly what they are and what they're used for. Classy lenses aren't really a new type of optic so much as a whole design pattern. Typically, one reaches for classy lenses to solve one of the following design needs: polymorphism over specific record fields, separating layers of logic without cross dependencies, okay, isolating the knowledge of a given module of code. I have no idea what that. The second and third one I think are a little confusing to me. The first one maybe makes sense, but we'll see. It's tough to describe these design concerns as bullet points, so let's see an example of some of the problems you run into with large apps and how classy optics help solve them. No duplicate record fields. Consistent annoyance in Haskell that you can't have two records with the same field names. Excuse me. The record accessors conflict with each other, so you need to either qualify them by their module or add prefixes to disambiguate them. Classy lenses provide an imperfect solution for this. There is also an extension for this although I don't remember how well it works. We have used it before. I think it's just called duplicate record fields or something. We have several records which all have a name field. We need to disambiguate the fields. The idiom is to use record name of field prefixes. Sure. Stick these in here and move that over. Sure, these can all be. Seriously? There's no code action for that? Is that something we can add? I don't know. It seems like that should be easy enough to include. Pretty sure classy lenses also work together with oh, okay, that's convenient. Not only is this annoyingly verbose, but there's a greater problem in Haskell as a whole. We can't write code which is polymorphic over record fields. If we want to print a record's name, we need a separate method for each record type. Even though the name field has the same type, there's no easy way to unify these almost identical functions. Greet person, greet pet. We see that each of them work as expected, but we need to use the corresponding function for each record type. Sure. This is where make fields comes to help. We've defined our record in this idiomatic way, i.e. with their record name and field prefix for all the fields. We can use make fields to generate record polymorphic lenses for all the fields. Let's see what this actually means. Make fields. Person. Which idea? First, import control lens. Second, language template Haskell. I think the idea for this is we're going to use a. Oh, okay, this is doing the same thing over and over again. That's kind of fun. So we need probably 3 functional dependencies is 3. Okay, we don't need these. They're probably implied by some other one, and we'll sort these. Yeah. Okay, Nadim answered that for me, so I don't have to. Wonderful. Thank you, Nadim, by the way. It's appreciated. So now we have this. Yeah, okay, here's the thing that we were talking about before, has name. Yep. It's a functional dependency between S and A. So given S, it'll imply the type of A, I suppose. Right? That's what this is, I think. Is that right? I'm pretty sure this is a functional dependency. Yeah, that's where this comes from. So I think this means like S implies A. So if you had a structure that's a person, it implies the type of A, which is a string. If you had a pet, it implies string again, I suppose. I believe that's how you read that. You can see that instead of making separate lenses for each record type, it has detected and stripped the record name prefixes and created a unified has name class. If we check info has name, we see it's generated instance for each of the records too. Has name is a field class, a type class which provides a lens which we can use to get or set a value of that field for any type which implements the type class. It wrote an instance for each of our records. You'll see it uses functional dependencies in the class definition. This helps us maintain type inference when using the field lenses, but you can basically ignore that. Okay. Here's how we can unify our 2 greeting functions. Okay, so greet by name, have name are string r io unit. R is kind of weird here. I would have guessed that they would use S for like structure, but it is what it is. We can use R. Like I would have guessed that it would be like S up here and R down here, but it doesn't really matter. Just being silly, I suppose. Hello. I have to sneeze. 1 second. Where's my mute button? Okay, I didn't have to sneeze. I really thought I was going to sneeze there. What is this complaining about? Oh, okay. Flexible contexts. Sure. You can have flexible contexts if you that's not what we wanted to do for sure. I did the exact same thing. What am I doing? Okay, greet by name. Pat. Andre. 3000. Andre. Okay. Cool. And then I guess we can do this with a person as well. Andre 3000 is also a person. So, hello, Andre. Nice. We did it. Okay. So, make fields may seem a bit like magic. It works by relying on type class instances. Make fields will look at the appropriate has star class. Has. Oh, okay. Because it. Okay, I see it. It's creating has name based on this. That's kind of cool, I guess. Strange. Cool. Do your best to have a canonical instance for each has star. If needed, you can define a separate module for that field, which calls make fields on a dummy record, then exports only the field type class for other modules to import. We'll explore that idea later in this chapter. Neat. Okay, neat. So let's try this. Separating logic. Should we make a different file? It looks like we should be okay to just continue here. So we're going to have a data environment. Hi, kitty. Okay, so here's our environment. Probably sounds very funny for me to just like randomly say hi, kitty, if you can't hear the cat. Very true. We got host name and a database URL, which will also be a string. Orino. Make lenses and format code. We didn't want to do that. There we go. Yes, I mean he's loud sometimes and quieter sometimes, so it just depends. He wants me to play with him, and I mean obviously I should be hanging out with him. We also need to stream. He's got food. He'll be fine. Food and water. Gave him plenty of hugs earlier. Don't worry. Okay, so monad IOM, monad reader, env m unit. URL u database URL. Be nice if the lenses showed up there. I'm kind of surprised that they're not there actually. Liftio. Start connecting the mat. Okay, so we need some stuff. So 2 for sure. Where's monad reader come from? Control monad reader sorry, trans reader. Is monad reader defined? So that's the MTL version. Where's the this thing? I think it would be a. But where is this in? Yo, I'm confused. What is? How did this work before with transformers? If monad reader is not a thing, didn't we just do this? Okay, we did not imply on, or we did not require monad reader, I guess. So what did we require? So can't use it as a constraint, right? Like this is just MTL style code. Oh, it is MTL style code. Okay. So yeah. This is fine. Okay. So package instead of using transformers, which is what I usually use, we'll use MTL instead. Um, do I have to actually build anything here? And then instead of this, probably be able to find this now. Probably 9. Okay. And everything should be happy again. Okay, so connect DB. Initialize. I've not done a lot of MTL, but I kind of understand. Was that something? All right, so asks port number. I need water. Bot. I understood the joke. I'm sorry, it just didn't make me giggle, I suppose. What is this? Oh, wait, please. I have no idea. Oh, here we go. Post view name. I probably should just copy this down, huh? So I don't have to type it. Okay. Sure. Have we done any letters yet? We have not, so this will be A. Run reader T. Env. Port 8000. Welcome. DB. I hate that dude. Initialize and What is this complaining about? Oh, I'm missing that. So I think normally what I would do is put a dot here, move the dollar there, and then that way I don't have unnecessary parentheses. Okay. Right. So the REPL was initialized with transformers, so we need to bring in the right libraries and stuff. Then we should be able to run A, and it should just do some things. Great. Oh, you even wrote great. So in this setup, we can notice a few things. The code is functional and doesn't have any problems per se, but both initialize and connect depend directly on env, and presumably so does every action in our entire code base that pulls config from the environment. This means that we've set a very rigid dependency on our environment type. If that type changes significantly, we'll have to fix our code across our entire app. Another issue is that each of our actions depend on the entirety of our environment all the time. We don't have any isolation guarantees, and none of the type signatures for our actions clearly communicate their dependencies. These global dependencies can either be really convenient or terribly dangerous depending on your organization, size of app, and privacy security requirements. It's up to you to decide whether this be bad. Okay. Um, Another annoyance appears when we eventually have multiple different contexts in which we'd like to reuse the app. What if we use the same shared database initialization across multiple services in our organization? With this setup, it's simply not possible unless all services use the same global env state. Alter the environment before. Okay, so database URL. This looks okay. So here we've changed the environment of connected DB only the piece it needs. Manually run the layer with the correct piece of main. This is messy and requires you to know your full monad stack wherever you do this trick, which is definite anti-pattern in empty style. Yeah, that makes sense. So we can use this magnify. This is nice, but it's still a lot of noise in our code. It gets very difficult. Okay. Granular dependencies with make fields. Using make fields. It depends what you mean by greater than. Like it's just different, right? Supposed to make things a little more easy to compose. Um, Granular dependencies with make fields. Using make fields cleans this up. We can define each field's class. Da, 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 da. In the module, which defines our database types, dummy DB fields record, which serves only to specify the fields which actions in the module we need. See an example. Comes that sneeze, y'all. All right, so I don't see how I'm gonna add some of this here, but yeah, that's fair. All right, so we have DB fields. Okay, so like DB fields is meant to replace this section, I guess, because it's really just a database URL, and then we just prefix it with the name type, and then we make fields. And I think that's an act. And then we get has database URL. any monad. Okay, that's kind of cool. Note carefully how we don't need to export DB fields or its record accessors at all. It exists solely to define the fields needed by the module. I also want to draw attention to the fact that the field prefix DB fields must be spelled exactly like this, or make fields will ignore it. Could be a bit annoying sometimes, so there's also make fields no prefix. Full. Okay. Now, when we define our env type, we import each of the modules which have fields we want to define. We still have cross dependencies, of course, but they've been inverted. The new dependency structure is much more modular, extensible, modular. Fix the issues we discovered earlier. For example, now our DB module can be shared amongst any number of services, which simply have to add the appropriate make fields calls on their env type to use it. We do, however, import the DB module just to get the instances in scope. Otherwise, make fields define new classes for each of its fields. It's a gotcha we need to be wary of, but take heart that our service would eventually fail to compile and alert us about the problem when we try to connect. When we try to run our connectdb action inside a monad reader whose env was missing the required instance. Okay. Cool. That's kind of interesting. Make field no prefix is also what you would use with duplicate record fields. Okay, that's what you were kind of saying before. That's just how you actually use it. Interesting. Okay, so this is some sort of inversion of control thing. So all we need is something called, we need a lens that's like database URL and string. And as long as that's the case, we can kind of just use that here. And then for every DB field that we'd want to have here, like if we wanted to have database port, then we would just add a database port here with like DB fields database port as a string, whatever, and we can do the exact same thing. It's pretty sweet, I suppose. And pretty useful probably for large applications. Field requirements compose. Benefit of field type classes is that they're specified with constraints and constraints compose. This means if we want to accept a record with multiple fields, we can do so easily by a multiple has constraint. Here's what it looks like if we give our initialize action the fields treatment. Okay, so we just want to be able to do this with init. Yeah, we need no prefix because we don't have init fields host name, fields port number. And this will work for any monad reader as long as it has a field called host name and a field called port number. And I suppose that if this was init fields host name, init fields port number, we just use make fields, this function wouldn't have to change at all. Excuse me. Okay, that's cool. Excuse me. There are a half dozen different ways to generate lenses using template Haskell. You'd certainly be given for getting them confused. This chapter covers the distinction between make fields and make classy. Let's jump right in and define a record. So data, person, and favorite food. Has name, has favorite food. Yep. Notion. Like a struct in C. Yes, these are very similar to structs, I guess. To be fair, I haven't written a struct in C in a long time. But yeah, you have fields with types, and some name, like person in this case. I think that if that's the question you're asking, if not, feel free to clarify a tiny bit, and I can answer it for you. I don't think there's an equivalent to these classes in C. Uh, so depending on what language you're familiar with, these can be called like interfaces or um, protocols. What else have we heard them called? They're called type classes in Haskell. I can't think of another name for them. So yeah, depends what languages you've used. So there's something very weird. Oh, trait. Yes, thank you. Oh yeah, okay. We might not be able to do this in other languages, but like the general concept is has a name. Um yeah. We call on traits. Okay, so let's see here. Sorry, I'm getting distracted. Okay, so here's our has favorite food thing, has name thing. Yeah, and that's generated by this. If we just add make classy, we get conflicting type class method names. Need to delete make fields before adding make classy. Okay. There's okay, I think they're okay. So we get as person, which is a person lens and a favorite food lens and a name lens. Interesting. So make classy has generated only a single class for the whole record, whereas make field makes classes for each field. So make classy is a bit less granular. It effectively allows you to specify that a type has a person nested within it somewhere. When manually implementing type class, okay. So our DB config would just be inside of the environment. Yeah, that's kind of what I thought. I don't really need to even look at this code that carefully to understand what's going on here. So like, yeah, we're nesting different components of our environment via some data type in this case, or some record in this case. Okay, using the what's up, Christian? How's it going? I still remember I don't remember who that was, but the there's like some high school students that have been watching recently, and they called me Mr. Chiroptical, which I thought was hilarious. Mr. C is I can't remember their names offhand. I think it was like Boded Boa and somebody else, but they were doing some programming in high school, and we played their game on stream once. It was pretty funny. Okay, so this is a little weird, but we can track it down. Okay, so there is an error with going on here in a second. Basically, it's trying to implement an instance has dbconfig as a field type class, but it's a classy type class instead. Wrote what? Make classy dbconfig, and then down here, instead of using make field or make classy, we need to go back to our roots with make lenses. Oh, okay, so env requires yes. Browse env class. Here, we're just delegating to the lens we generated with make lenses. Observe. Okay. As you can see, each approach lends itself to different styles. I'd say make fields is more helpful for reducing the annoyances of records with shared names for implementing field polymorphic functions, whereas make classy tends to scale a little better for large projects. I could see how that would make sense. I kind of like the make fields approach. Also, this last little trick sort of threw me off. Yeah, see which one's for sure. Okay, sweet. Wow, we've done a lot of stuff today. Um, can't spell. Good. Okay. So for I think pretty much everyone's been here this whole time, but just a reminder, this is the book we're working on, Optics by Example, and the code that we have is on GitHub, and I just continually push it as we're working. No big deal. Okay. How long is this chapter? So we've only been streaming for 2 hours. So like, sorry, 289 04. Only like is basically. So we can probably finish this today too. Let's go for it. Okay. Uh do 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 do. Okay. Um what do we need here? So package, clearly gonna need lens. We're gonna need ASIN, and we're gonna need, I always forget what this is called. Copy, but raw strings QQ. Of course, everybody knows raw strings dash QQ. Okay. I don't know that we need anything else at the moment, so we'll see how it goes. Do we need ASIN lens as well, maybe? Are those separate packages or are they the same? I bet they're the same package. Guess we'll find out after. Uh test. Didn't take very long. I would guess that it doesn't need to compile ASIN at this point because I keep using the same resolver for everything. Do so this becomes put stir len ASIN import control lens. Actually, I'll just let it do this for me. I don't know why I would write that by hand when I let this me. Okay, so JSON values are effectively on type. More accurately, they're part of one big type. Yeah, it's some any type, right? ASIN calls this JSON catch-all type value. When we have a value, we know it's valid JSON, but we don't know what sort of JSON it is. It could be a number, string, array, object, boolean, or even null. JSON. If you've been following along with the book so far, hopefully you're thinking prisms. Yeah, that would make sense because like kind of pattern matching on things. We do need lens ASIN, so let's go get it. We're gonna have to compile it, I assume. Um, I was gonna guess that it was ASIN lens, but it's the other way. Awesome! I almost wrote. So we'll get that building while we read. Oh, it seems like it's going to be easy to build. Here's a list. Prisms provided to us will represent a JSON-like type as T. So some string is a prism to text, bool is a prism to bool, null is a prism to unit, object is a prism to hash map, text value. That's I guess that makes sense because you're gonna have a key value for any object, right? And then an array is to vector. Sweet. There are also several numeric prisms which automatically convert the generic JSON number type into whichever you'd like to work with. I imagine that prisms are actually super sweet when you're working with JSON. Of bubble water. Did you know that Lens does not compile on machines with I suppose that would make sense because Lens is a pretty heavy library, right? Yeah. I imagine you also probably can't compile ASIN on a machine with like 1.5 gigs of RAM. ASIN's pretty big too, isn't it? I know that like ASIN takes quite a while to compile on a fresh machine. Like visually amount of time. Okay, anyway. All right, so let's go into here. Sorry, source lib, and then we will just start messing around with this. Double. Man, I can't spell. Okay, so we should be able to get 4. And can we get... We can't get it to tell us about double. Oh, it doesn't even want to do that. So import control lens, import data ASIN lens. I think that should give me enough. ASIN's pretty simple. Well, okay. It feels like it compiles very slowly on my machine, I guess. Lens certainly takes a long. Okay, so A should be just 42.0, I suppose. Are we even in the right place? We are not. Yeah, perfect. 42. Does that really return a text? It... Oh, okay. It probably needs to be like this. Yeah. Because 42 is a number in JSON, right? Hey, Tom. Why are you streaming and not working? Because I am off this week. Speaking of which, I should text you because I meant to do it yesterday and I didn't. So actually, let me do it now before I forget. Do it on Discord. Just give me a second, peoples. Okay, text out. Back to work. To you too. I don't know. I don't think you. Yeah. Anyway, we can talk about this. We can talk about this. Okay. So yeah, we're celebrating freedom holidays right now. All right, so invalid JSON, we just saw that because this actually kind of behaves like invalid JSON. If we escape them with actual quotes, then we get the things that we expect. But if we try to obviously use a prism to view this as a double, it's not going to work. Okay, that makes perfect sense to me. Well, New Year's isn't really a religious, but each prism will short circuit the entire path if it fails. This makes composition really nice and easy. Unfortunately, it can also make it a bit tricky to find where our assumptions about the Json shape were incorrect. Let's try digging into some of the more structured JSON types. We'll use the R quasi-quoter to avoid escaping things. Sure. So C will be R rank. What is JQ written in? Does anybody know offhand? I'm genuinely curious right now. This. And then this should complain it's unable to figure out that we need language. What is it called? Just quasi quotes, right? Yeah. Um, two. We've just been doing generic imports, so let's just keep doing generic imports. There may be a reason that we need to do that. Okay, so this is just, let's just call it, I mean, we can just use object. That's fine, actually. JSON. Yeah, we'll have to see what this gives us over the other thing. Like I legitimately don't know what this is going to end up looking like. You know what I mean? Like if this is really all that useful or not. Uh Okay, so Earth. Oh, I need. Hello? I don't even know what I'm typing right now. East? West. Obviously how you pronounce that. East and West. Okay. I highly doubt you can have a trailing comma here. I think we actually had an issue with that in one of our other libraries, or not library repositories a little while ago. Okay, so it's very useful if you want to pull a single field out of some huge JSON. Yeah, I mean, I'm kind of the whole thing. Yeah, English is hard. There's some very weird rules about pronunciation. Okay, so now we have like some example objects to work with. So I suppose C can just be JSON object. Here comes that sneeze again. It's gonna come out eventually. Okay, finally it came out, which is really nice. It's been bothering me for a while. So if we try to view this object, I suppose that this will compile and it will give us like a from list. Is there a field? Like what if we do field name? Is that a thing? Um oh, there's something hash map object. I want to reach in to like some arbitrary field name text. How do we do that? I doubt that there's like text. The string is a anyway. Not sure. We'll figure it out eventually, probably. So we can reach into an object. We can probably reach into an array. Key. T. Is this the lens though? Right. T dot pack. I'm gonna try to avoid adding strings here. I'm sure we'll learn about key here in a second. Oh, okay. Package text reload save. Yep. No instance for as value. Okay, I was guessing that we would just compose them like this, but we'll deal with it. We'll deal with it in a little bit. So, oh, right. Reload this. We could also just set package, but I feel like that's easier. Wouldn't I need to reach into the object first? Maybe I don't have to. I guess we'll learn. I'm not gonna jump the gun yet. D. Here we go. Hangs. Hard. Okay. I really don't want to copy and paste this because it's gonna be pretty horrendous. We'll see how bad it is. At. I'm sure we'll learn about these things, so I'm not terribly concerned. Okay, so name all of this needs to be moved out, and then this is a list. I could have moved this as well, and then this should also be moved out as well. Hey, Ratzenplatz, how are you? Key does not work with hash map. So here's this. All right, yeah, well, the other thing is at. I don't remember how at works. There's just like a lot of little lenses I have a hard time about. At would be. Oh, they're indexable. That's useful. So we could have done x, I think. Dot x name, I guess. Oh, but okay. This we would need t dot pack. Okay, cool. So we can also use x, which makes sense, I suppose, because a hash map is an indexable structure by its key. Very cool. Okay, so now we look at the object name crew. We reach into the crew, which an array. This feels awkward. I would have guessed that. Yeah, that's okay. I mean, I'm fine with you guys getting ahead of me. I think a lot of it I can kind of figure out, but the key was not obvious to me. But I guess it's just like doing the thing. This is a little awkward to me. I would have guessed that X crew just returns an array. Like, why do I have to? Oh, because I want to use x0, I have to reach inside the array. That's what I'm doing. If I just had x crew, like if I just had this, I guess it would return the array itself. So E. So if we have E, and we do black Perl, view maybe, object dot x crew, we should get a sorry, t dot hack. I'm not gonna turn on. Probably should just turn on overloaded strings, but I don't feel like it. Then we get an array of objects, right? But then we want to reach into the array and grab out the first element, which is why we need these. That makes sense. And then we want to reach even further and grab the name and just return the string instead of the object with the string in it. Okay, here's key. Thanks, Twitch. Very kind of you. Well, happy to see you here, Odds and Plots. How's the free BSD stuff going? Oh, geez. I don't know how to pronounce your name. There's too many ways to put it together. So maybe it's just, I'm just going to call you Chum for now. Thank you so much for the follow. I'm sorry, I totally missed it. I think that maybe if I saw you chat in here, I would have seen that. So I apologize for missing your follow. But I hope you've enjoyed what you've seen so far, and we'll keep it up. If you have any questions, obviously feel free to ask. I'm here to answer as best I can. Not that I always know the answer, but I will try. Free BSD stuff is going great. Nice. It's good to hear. I haven't been able to catch one of your streams lately, so busy with. All right. This works, but it's long, hard to read, and easy to introduce mistakes. So here's the traversals that we get for this. Key and nth. Kind of interesting. So key is just object.ixk. Cool. So I see. So the key just pulls out the object like we were talking about before, and nth just pulls out the array. So that's cool. So we can look for the key, true, nth 0, key name, string, and we just get the captain. That's pretty thick. So let's put that whole thing in here, and then the shortened version. Dot array dot x0 dot string dot x name dot string p dot tag. I've actually thought about creating like an extension similar to overloaded strings, but like always text. So it would be super nice if we could just have like every single what is the term for this? String literal is just text instead of having to do this all the time. Yeah. I don't I beat you in text, but you probably thought about it before me. Or from the chat standpoint, because the chat's behind, obviously. Okay, so this is the same as Black Pearl. Key tpack through dot nth 0 dot string, I guess. So we'll reload this. E F. Oop, I missed something. What did I miss? Oh, I missed key tpack name dot string. Yeah, so like this would be super tricky here. Overloaded strings would work in this case, but there are some cases, especially with lenses, where if you use overloaded strings, very weird things happen. You have to like it can be hard to even coerce the string literal to the type that you want. Like even if you say like name colon t dot text or whatever, it still needs more help to get you to the final result. So it would be nice if you could just be like, every string literal is text, and see if that does anything. Yeah, I think so. So what I would do in those cases is just use type applications and then just basically uh, tell lens that just use text for this thing, and then you don't even have to specify. It'll figure out, like, overloaded strings will figure out the rest. But I don't know if maybe if using always text it wouldn't actually fix the problem. I don't actually know. Okay, so tracking down mistakes. This seems like it would be useful. Since we're mostly working with values of the ambiguous type value, it's quite common to make mistakes in our lens path. When writing traversals like this, I recommend loading in an example value into GHCI and building up a path one section at a time, checking the intermediate results as you go to verify your assumptions continue to hold. Yeah, I mean that makes. So traversing into multiple JSON structures, sometimes we need to collect or modify values from many spots within a JSON structure. Maybe we have a list of users and want to collect all their email addresses. Perhaps we've got a large Kubernetes configuration and we want to find the specs for all pods with a given tag. Using a traversal, we could even make an API call to replace an ID inside our JSON. Traversing. One of the most common branching queries. Okay. um, Wonder if it might not be better to use ASIN to convert the entire JSON value to a Haskell value and then use lenses on that. It's a good question, but then you have to define the whole shape, right? So, like, I think maybe the lens is more useful during, like, the exploratory phase. I don't know. That's actually a good point. Like, why not just define the whole thing and then just use regular lenses that are, like, built from lenses, or make lenses is what I mean. I don't know. But, like, yeah, I guess this gives you the opportunity to, like, not define the whole thing if you don't want to. You can just define parts of it. So yeah, like for exploratory data with like a big chunk of JSON that you don't really know you don't want to write the whole thing, then maybe this makes sense. Are we done with this? So, it depends what you're doing, I think. Like if you're writing a web server, you're certainly gonna be writing the response types out by hand, I would guess. But like if you're just given a big JSON blob and you're like, I just need these little pieces, and you're not trying to write an application, maybe this is more useful. I'm not sure. I'm just guessing, obviously. Okay. So we get a traversal called values. And it's just array.traversed, sure. And we can say to list of values to integer. Remember that if any elements of the traversal don't match our assumption, they'll likely be silently excluded. Unlike Haskell, JSON allows arrays with differing value types, so it will just ignore them, which may or may not be what you want. Yeah, I mean, why wouldn't you just bracket all the things? Everything's a dictionary. Uh, in Python, we're talking about. See that you won't see the chat. Note that it's actually the integer prism which is filtering out possibilities here. Values focuses every array element, but integer pattern matches only the numbers. Values is an index traversal int, so we have access to the array index even after we've descended into each element. Here we return the index alongside each element using the indexed I to list of operator. Okay. So let's write this one in here. Kind of weird. Suppose. So we're trying to get just a list of ABC, I guess. Oh, right, but we're using the indexed one, so we also get back the indices, which makes sense. If we just got rid of this and reloaded it, we would just get that. So this ampersand basically is indexed traversal. We learned about in chapter, whatever chapter this is, 11. Okay, we got values, cool. We can ignore stuff, which may or may not be good. Um, oh, that's kind of interesting idea. So it's like if you did have nulls, you could just like look at the indices that come out, and if you're missing things, then you know that you had like null data, which I suppose is kind of cool. Remember that as we're chaining together traversals and prisms, we can modify our focus. Sure, that makes sense. The values traversal will even return the result to its original encoding, in this case a string. Oh, right, because this is modifying JSON itself, so that's super cool. Um, actually, because it's a prism, we can actually, modify JSON in place, going through list of string in this case. So that's super cool. So here's a use case that you don't get from ASIN, I suppose, right? In ASIN, you'd have to parse, do the thing, and then send it back to JSON, I guess, which isn't that hard. Right? It's not like you're gonna lose your mind, but prisms are really cool for this. So I think that's kind of interesting. Yeah, so the index stuff we did on, I want to say last Thursday. If you wanted to watch that one, Prutz, that was, I think it was indexed. Anyway, it's like chapter 11, so you could just look at the vods. It should still be there for a little while longer. Okay. Um. Here's a sufficiently, I can say words, complex JSON for us to work with. Okay. So unfortunately, I wonder if I like use. Nope. I was hoping that maybe this would behave more nicely if I used copy and paste, but it did not, as you can see. Okay, so these crew members should be one A, and then this. Oh, right, this whole thing needs to go as well. There we go. And then we have another, this thing. These all go out to here, and then I guess go out one, and then these need to move out as well. Again, we're just like, you know what I should do is feed this through JQ and just, it would pretty print it for me, and then I wouldn't have to do all of this manual formatting. That would have been useful, but oh, I didn't do. Okay, so we basically have two objects, a Black Pearl ship and a Flying Dutchman ship. Let's say we want to collect the names of every ship in our fleet. This is a branching query where we want to select a specific piece of info from each ship in the top level query. A helpful technique when trying to determine how to lensify a JSON query like this is to think of what the traditional JSON path would look like. JavaScript notation. I've never written JavaScript in my life, really, so that's not helpful. But I can kind of see what we're doing here. We're like trying to sort of say, for all i's, but we don't know what I is, give us the names. But it's pretty clear well, not that clear, I suppose. Uh, Fleet to list of. So values will give us all the values, but we want the key name dot string. Yeah, I guess that's true. It's pretty much the same as Python. That's fair. Um, which I've written a lot of Pythons. Keep doing the wrong thing here. I also always forget that I can just write colon. I don't actually have to write colon R in GHCI to get the thing to do what I want, which is super helpful. I think we only have like 8 pages left, which is good. Getting hungry. Yeah, it's like a silly little thing. Like there's probably it would be sweet. Okay, so somebody who was it? Empress or actually I don't know. I don't know if it. I think it's Techno Empress. So woman. Um, that's what it is. Again, checking it out. Dude, give me a second. Trying to find this out. Anyway, they were talking on Twitter about doing like a newer version of GHCI. They were comparing. I think uh, what's his first? Andre Sereno Mena. Andre. I think Alejandro did a post comparing the REPLs for GHC and Elixir, and then Techno Empress pointed out like maybe it's time to like write new GHC. I think that would be pretty. I don't know what you would do to make it better. Anyway, uh, yeah. So okay, so from what if okay, so if we're just like messing around with R, if we do R, it basically reloads everything. So it just copies everything underneath it. So I think it's like reload or something. Or replay or something. Yeah, like syntax highlighting. Like one thing I was thinking about is like what if this was like a brick application where you could like set and change a few things? That might be interesting. It's yeah, it's pretty good. It just could use a like a little uh maybe just slightly prettier, something like that. Okay. So let's go even deeper and get the name of every crew member in our entire fleet. Yeah, I mean this is starting to just be repetitive. Like I kind of understand what's going on here. You can change the print function I use. That's cool. Okay, so if we remember some clever tricks from the section on index, oh, you might like this, Pretz. So this is going to be kind of cool. So, so we can use that thing to list of with index values, and then we can use this reindexed function. Kind of wild. I'll explain this in a second. Let me move some stuff. Can't type. Losing ability to type. Okay. So what this is doing is using a self index to give us the index for every self. And then what we're doing is saying using that self index, which is basically the keys, go reach in and grab the ship for that name, and then use that as the index. This thing says ignore the index of the right side and just keep the index of the left side. So that's our ship name. And then here we just go in and look for the crew members for each ship. So you can see like this gets pretty wild, but it should work, and yeah, it does. So there's Black Pearl, Jack Sparrow, Black Pearl, Will Turner. So you can do some pretty wild stuff here. That's pretty sweet. Okay, so traversing objects. We've learned how to simultaneously focus all values within a JSON array. But what about objects? Sometimes JSON objects are structured, so we want to access all values at once. For instance, if we had a map from user ID to user and wanted to focus every user at once. For this, we have members. Okay, so members are a text to value. Our enterprising pirates could never quite understand the merits of spreadsheets. So they foolishly decided to use JSON as their primary inventory system. Yeah, that seems like a bad idea. They're keeping track of their cargo as a JSON object mapping between item type and quantity. Pirates are going to be a world of hurt. This is a maintenance nightmare. I don't know why that's so funny to me. Okay, let's start off simple and see if we can list all the quantities. Maybe even take count of all the items on the board. Okay, so on board, not on the board. So J is cargo to list of members. So that's like all of the keys. And then found full. Oh, integer. There. J. Cool. And then I guess we could just do to sum. To sum. But that's what it was. At? What's the difference between at and to? Certainly not. That doesn't work. Can't remember. This might be like an issue with like parentheses needing to be in the right place. Oh yeah, maybe that's all it is actually. Maybe it's just like that doesn't quite work. Not sure. At is kind of like ix, but only for maps. Oh, okay. Ix, but only for maps. So like anywhere you could use ix, you could use at. I guess if it's a map. I'm trying to think of how like you can use some of on this one, but maybe this is actually more readable in the long term. Ah, okay, I see. I'm not surprised that that doesn't work. No, knowing the quantities isn't so helpful unless we know what it is we're counting. Read the key alongside the quantity sounds like a job for index optics. Yeah, that makes perfect sense because the index for this it's a hash map, right? So, or members is the hash map. So the index is just text. IJL cargo at that members dot integer. That makes sense. This properly parses the input into an object, validates and parses all the values as integers, then includes the keys as text alongside each value. Luckily, integer is an index preserving object, right? So there's, so we don't need to worry. I see. Okay, so it actually underscore integer wouldn't have worked if instead it used these keys this way, but it's index preserving. Okay, I was thinking that it was index preserving, but it didn't have to be. Could have been. All right. Let's say we want to know which item we have the most of. Here. Should be able to get this automatically with index. This is interesting. Unfortunately, there's no I maximum of. Oh, I see. So we need to explicitly include the index. I get it. Very cool. What if there is no maximum? What is it? What if there's a tie? 621. Just prints the first one it finds. That's probably just the behavior of comparing, I guess. Okay, so filtering. We are already collecting info from across our huge JSON blob like a pro, but it's not that huge. But oftentimes we need to ask more complex questions. What if we only want the IDs of users whose accounts have expired? Let's try to find only the crew members in a fleet who are captains. The trick with this sort of query is that we may filtering it on a different aspect than we return from the query. Okay. Do we have ranks? We do. Okay. All right. And I'd like to be done with this. I'm getting tired. To list of values. E T pack crew. We did do 3 chapters today, so it's not that surprising that I'm a little tired. Values filtered by a rank dot string probably. Oh, only. That should be a string. I should have turned this on a long time ago, but oh well. Oh, I'm not done. Key. I also don't think that this is supposed to be. I think this is supposed to be this. Okay, so filtered by key, only captain. What did we screw up here? Couldn't match type. List of car. I needed to close my door. Uh, values, key value, filtered by key dot only captain string. I mean, it looks right to me, but it. Okay, expected type. Const monoid first wants a value, and we're giving it a string. Oh, right. So this is the problem here is that overloaded strings is doing some work for us. I think that we can just use val. Is that what it's called? How do we? Yeah, it needs to be a value. How do I generate one of these things? We probably have string, so we can just generate one. There we go. So we'll use the fact that we have a prism to just generate the thing. Ay, ay, ay. There we go. Well, no, it's okay. Yeah, the error is unrelated to overloaded strings, but if we were using overloaded strings, it would be able to coerce this into a value. It can coerce a string literal into an ASIN value, which is why this compiles. Okay, so cool. We did a thing. Serializing and deserializing in an optics path. You've probably seen it can use the prisms provided by LensJSON to deserialize the standard JSON types like objects, arrays. Let's see how we can reflect values from their value representation into their structured Haskell forms and back within a traversal. Okay, so data. Uh, it's using from string. Oh, I see what you're saying. Why is that the case? I'm not exactly sure. I don't know why that works, to be completely honest with you. But it does. Okay. So, driving strategies. Data ASIN 6. Okay, fair enough. Totally fine. 3. 4. Okay, we got all the things. So I haven't used this deriving thing that much, but I like deriving stock is like a standard deriving clause when you turn on that extension. I'm not exactly sure what any class means here, but clearly we're doing something to convert to and from JSON, and We'll have to see what this ends up looking like. I suppose we can just reload and then do like what? Object. Not object. Yeah, I guess it would be object. Materialize. Sorry, import control lens, and then value port data Json lens. And is there a value? There is. So materialize creature hello 12. Couldn't match expected type. Isn't that what we would want to do? I don't know. Somehow we can convert this to an a JSON object, but I don't exactly know what it's going to do. So anyway, we'll see what happens. Okay, so with derive any classes you can, well, derive any class. It won't implement any methods, so it relies on default method signatures and implementations. Okay, we'll have to see what that means in practice, I guess. All right, so let's see if it's faster to do a thing. I suppose this is faster. Like a type. Really like JQ. Okay, so specifically in this case, toJSON and fromJSON have default signatures and implementations for anything that's an instance of generic. Ah, okay. So if we, okay, we'll have to see what that ends up looking like, but we could have done deriving stock toJSON from JSON generic. So I'm definitely curious to see what's different once we write a little bit more code. Okay, so where are we at? I think we were at N. I'm actually very interested if we just change. Okay, so this looks like, oh, well, this is, right, this is coercing the creature sightings into a list of creatures. So this is the serialization, which we expect to work just fine. And clearly we have a Json Prism, which I didn't realize before. So we should be able to just do JSON and then creature Kraken 124.4. Really? Yeah, that's what I'm still unsure of. I wouldn't have guessed this to be a problem. Okay, let's see. This introduces the Json Prism. It's a prism which can convert between any JSON-like T and any type A, which can be serialized to or from JSON value. Oh, so string? Yeah, there we go. Okay, so it gives you creature name and this as fields like that. Let's see if anything changes. If I just do, that is not how you do comments, to JSON from JSON. Oh, okay. So because we're this is just, I think this is something to do with it's the extension, right? with deriving any class, I guess we need this. Something like that. P. So we just want to you can derive them without any strategy keyword for the same effect, but you can't use the stock strategy. Yeah, I guess it's not. I think when you do to and from JSON like just normally, oh, I see a hydrate up there. Sorry, I'm paying a lot of attention to what I'm doing at the moment in the chat. Not like looking up high enough. Okay, I want to finish this chapter. Let's push ourselves. 2 pages left. We do need to specify the type here because it's going from no, do not apologize. I'm just not being trying to like stay super focused. I want to okay, so while we're at it, let's see how JSON allows us to write back changes we make to the record representation into the original JSON blob. When defining our creature, oh, we already did that. Make lenses 4. Specified to create lenses for each field by making mapping a field name to the name. Not seen this before, but I suppose this makes sense, like just reading it. Parse error. Can this not be on multiple lines? Parse error. Oh, I've not even used template Haskell yet. It's kind of funny. No, I don't. Goodbye. And forever. I wonder if like anyone who's ever watched on YouTube hears that. They're like, what is he talking about? Okay. What are we doing? Lost my train. Oh, right. We were having a template Haskell snafu. Okay. Parsons has this somewhat fastidious but pretty interesting blog post that explain most of what there is to know about driving. Oh, yes. That sounds useful. Pin, please. Shall pin for later. Thank you. Okay, so now we have these lenses. So we could creature sightings, members, value, JSON, creature size L. Dude, that's pretty wild. Q. Well, we don't need put Sterlen. Creature sightings. I guess that's probably what's coercing it into a string or something. So members, values, JSON at creature size L 1 point. Need type applications. I feel like type applications is one of my favorite extensions. This is kind of a weird formatting, but okay. I mean, I guess it's not that weird, is it? Because this is like constructing the path to the land. So it's actually kind of a clever format. That compiles, but does it work? 8. So they've given a 20% modifier. This paragraph, but okay. It's kind of an interesting thing to do.